This problem is asking, given a graph of a function, to graph the graph of its derivative. Okay, so here we need to draw a new set of axes. Okay, directly below. That's the easiest. Let's something like this. There we go. Okay, and now we need to look for important features of the original function. So when we look at the function like this, the first thing we need to look for are potential, if it has any zero derivatives. Okay, so for example, here I see that the derivative is 0 at 3 points. Okay, zero derivative, remember, it means horizontal tangent. So it has a horizontal tangent at these 3 points. One is clearly 0, the other two we don't know, okay? But that doesn't matter. Doesn't matter much. So now these points are important, so we bring them to our new graph of the derivative. Okay. These are the points where f prime is 0. So that means the graph of f prime needs to cross the horizontal axis at these points precisely, no other points, only these ones. Okay. The next thing we need to see on the graph are the places, the regions where the derivative is positive. Okay. Positive derivative, let's do that in red. Positive derivative means a positive slope for the tangent. Okay. So for instance, we have it here. All right. Well, what happened? Oh, well, never mind. There we go. But then we can also have negative derivative, which could be, for example, here, those are negative derivatives. Looking at the original graph, we see that the derivatives need to be negative on the far right, right? Because we see the slopes, and in the middle left, and they have to be positive on the far left because the slopes are clearly going up, and in the middle right. Okay. So, well, let me put this over here. You'll see why. Our function then needs to live somewhere here. It has to live here, here, and here. Okay, because that is where a function can be positive or negative. All right. So with this information, we are pretty much done. So we have a positive function on the left, so it will be something like this. Then we have a negative function on the right. It will be something like this. And then somehow it needs to cross. So you see it cannot cross from top left to bottom right because we know that the function needs to come from the bottom left and up to the top right. Okay. But then somehow you see when we enter this region, we are going down, we need to leave going back up. Okay, so that means that at some point there has to be a turning point, and the same thing happens in the other region. There has to be a turning point. Now these turning points are very important, okay, and we can see them in the original function. Let's, yeah, in the original function, let's use some color we can see well. there are these points here that are called the inflection points. That is where f changes from concave up to concave down. Concave up means curved upwards, concave down means curved downwards. And if you notice here, let's zoom in. Here the function is clearly bending upwards, and here on the right and also on the left, the function is bending downwards. Okay, so here we are at this point precisely, we are changing from a concave up to a concave down. Okay, that is an inflection point. And the same happens here. We are changing from concave down to concave up. Okay. Also, the inflection point is the point where the slope of the tangent is the steepest. So notice here that we go from horizontal, slowly increasing our slopes more and more positive up to this point where the slope is the steepest. And then it starts slowing down again until it becomes horizontal. Okay, so that point of the steepest slope is the inflection point. Same thing happens, it can be the negative steepest slope. Okay, so in this case we go from horizontal more and more negative until we reach the steepest, and then we slow down again to 0. Okay, and when we look at on the graph of the derivative, we can see the inflection points that are a minimum and a maximum of the derivative function. Inflection points, and we should label them, okay, so that it's clear where they are and that we know what we are saying. Okay. But notice here again, I was saying that here the slope is the negative steepest possible, so that means it's a minimum, and from there it just goes back up. And here is the positive steepest, like the largest it can be, so it's a local maximum, and then from there it goes back down. So this is the graph of the derivative.